since we know that, okay, this is like us as data analysts having to learn about statistics now, the basics aspect of statistics that can be related to your career as a data analyst. Yes, so that's basically what this means. So what we'll be doing today, we'll be learning the basic statistical concepts that are very important to the career of a data analyst. So we'll get to learn about things like mean, median, mode, standard deviation, and also how to um, interpret these statistical computations into meaningful data, right? Meaningful data that is understandable by everybody. It's understandable by the most audience that you might want to interpret it to. So if we correlate this back to data analysis, you'll see that this is like the last phase of data analysis, which is sharing your results, your data visualization and everything. So statistics is also the statistical techniques and process is also somewhat similar to the data analytics techniques and process also. So the objective of today's class is that by the end of this class, you will all learn the concepts of mean, median, mode, and standard deviation. Not only that, not only that, you'd also learn how to calculate the statistical measures and also interpret the results of these statistical measures also. So that's what you'll be able to benefit from at the end of this class. So that's something you should take note of. So bearing in mind, most of what you'll be doing as a data analyst would be a mix of these statistical principles or statistical ideologies. So that's why statistics is also kind of important as a data analyst. It's also very, I would say, very, very important as a data analyst. Your job or your career path as a data analyst, statistics is very, very important. Okay, so in a broad sense, what statistics? Like I said earlier, statistics is a branch of mathematics that deals with collecting, analyzing, interpreting, and presenting data. So it's a branch of mathematics that deals with collecting, analyzing, interpreting, and presenting data. So you first need to collect the data. So once that data has been collected, you now need to analyze the data. Then after analysis, already the analysis itself gives you some form of interpretation, or it points you towards the direction of how you can actually interpret the data that has been analyzed. So after interpretation, you already know the messaging or you already know the inference you've received from the analyzed data. That means you can now share it with others. So that's where presenting comes in. So when you already have your interpretation of the data you've analyzed, it means you can now educate others. You can now share your results with others. So that's where presenting data comes in statistics. So the importance of statistics is that it summarizes large amounts of data. So things like population, census population is gotten out of statistical efforts. Things like calculating the annual WAEC or the JAMB performance of students across um, different geopolitical zones, or even maybe across the 36 states and capital. That's also born as a result of statistics. So it helps to summarize large amounts of data also provides insights and trends. It also facilitates decision making. So these are the importance of statistics you should take note of. So it helps to summarize large amounts of data, then it provides insights and trends, and also helps to facilitate decision making. It helps to facilitate decision making. So out of all the statistical methods or concepts I've briefed so far from the beginning of this lesson from the cover page. So I'll go into them one by one now. So we'll start first from what's called the measures of central tendency. The measures of central tendency. So the measures of central tendency is a subcategory under the branch of statistics that talks about the identification of a single value, the identification of a single value that can be used to represent the range of other value in a particular set. So it talks about the identification of a single value that can be used to represent or estimate the quantity or the measures of the other values in a particular set. So for example, what do I mean? So take note, I mentioned sets. So a set is like a collection of values. So 1, 2, 3, 4, 5. So that's the set. So we have the number 1, we have the number 2, we have the number 3, we have the number 4, and we have the number 5. So we're in that list, in this particular set, right, I have 5 digits. 5 digits. I have 5 digits. So this is a set because it contains a collection of values, or in this context, collection of data. Yeah, so we say measure of central tendency is the process of getting or identifying a single value that estimates the rest of the value in the entire set. So which value in 1, 2, 3, 4, 5, which single number can I use that will give me a best estimation of the other numbers that I might be expecting, the measure of the other numbers. So that's where we now have a statistical technique whereby we need to calculate the central tendency in a way that it will give us something close to every number. So it kind of centralizes all the numbers that might exist in that particular set. So it tries to get the center of a particular data set or a particular set. So the center value. So what this means is that there are different ways of calculating central tendency, right? But the goal of all of them is to get a single value that can be used to estimate the rest of the values in the range. So one of these methods is using the mean. The mean. So the mean is something we might already be common or familiar with. So mean can also be called average. Yes, mean can also be called average. In basic mathematics, it's usually called mean. Then most times statisticians refer to it. In basic mathematics, rather, it's usually called average. Yes, average. Yes, but statisticians refer it as mean. So the average person, the everyday person would usually call it average. Yes, but it's still the same thing. Mean, average. It's still the same thing. So mean, how the mean formula works is that it sums all of the data points divided by, it sums of, take note, it sums all of the data points, then divide it by the number of data points. So in the example I gave, I said 1, 2, 3, 4, 5. So we have 5 digits in that data set. Right? Then divided by the number of data points in that set. So we have 5 data points. 1, 2, 3, 4, 5. So if we were to count it now, 1, 2, 3, 4, 5. So it's 5 data sets. So if, okay, let me use the example. Let me use 10. 10, 11, 12, 13, 14. 10, 11, 12, 13, 14. Yes, 10, 11, 12, 13, 14. we have 5 data points there, because if we start counting from 10, 10 is one value, 11 is 2 values, 12 is 3 values, 13 makes it 4 values, then 14 makes it 5 values. So that means it's 5 data points. Yes. So data point is just a count of the number of values in that data set. Yes. So it's telling us that to calculate mean, we need to sum all the values together. So 10 plus 11 plus 12 plus 13 plus 14. So what we get by doing that, so we'll actually practicalize it now and see what we get by doing that. So 10 plus 11 plus 13. Okay. So I'm sharing my spreadsheet screen now. So we'll just do a bit of practice for that. So let's say we had a list of numbers. The numbers are 10, 11, 12, 13, and 14. So what are the number of data points we have here? So the number of data points you have is the count of all the numbers occurring in that frequency. So to do that, we can use the count function to count. So we'd say count, open brackets, open square brackets, A2 to A6. Yes. So this is giving us 5. Yes, so it's giving us 5. Let me take this down here. It's giving us 5. So these are the number of data points in this particular set now. It's giving us 5, right? Then remember our formula said the sum of all data points divided by the number of data points. So our formula said sum of all data points. So we need to sum all of these data points we have here. So this means 10 plus 11 plus 12 plus 13 plus 14. So ideally, originally, using the crude paper and pen method, right, would have to actually sum all of those together. But through the use of digital technology, using a spreadsheet tool like Microsoft Excel or Google Sheets, you now know that you can leverage on functions and formulas. So through a function, you can just use the sum function. Use the sum function, impute the sum function, then you specify your range. You specify the range that you want to make the calculation to. So from A2, so you need to bear in mind, you need to know the cell address that I want to reference. So our value started from the cell A2, then ended in the cell A6. So that means we'll be referencing from cell A2 to cell A6. So once we sum it together, so we can now see that we have 60 as a value. We have 60 as a value. So the sum total of all the data points here is 60. So the mean, remember the mean is trying to get us the center value, right? The center value that can be used to estimate or represent the rest of the values. So even if it's not very accurate or close to the rest of the values, but it just provides a way to at least estimate closely to any of those values that are currently presented in the set. So this means that the sum of all data points divided by the number of data. So to calculate the mean, in this case, we have the sum of all data points, which is 60, right? So reference this C2, which is 60, right? I'm just referencing the cell that had the sum together. Then C3. So I'm now referencing the cell that had the counts. That had the count of all the data points. So if I impute this now, We're now seeing that using the mean formula, right? Using the mean formula is now telling us that is 12. So the mean in this range of data here is 12. This range of numbers, rather. The mean is 12. So looking at it, let's take a quick observation of the data we have in our list. We have 10, 11, 12, 13, 14. Yes, so remember, it's measures of central tendency. Central is trying to get the center trend, the center tendency, the value that is most likely to occur at the center, meaning that it's at the bridge between the high values and the low values, then also covers the moderate values. Yeah, so if you take a notice here, this list I have was arranged sequentially, right? It was arranged in order of sequence from highest to lowest. But if you take notes, there's a coincidence. 12 is the middle number here. 12 is the middle number. We have 10, we have 11. Then 12 was the middle number. So this now takes us to the next concept. This takes us to the next concept. So the next concept is actually median. Median. So median, how do median get calculated? Median gets calculated by getting the middle value in a sorted data set. In a sorted data set. So take notes, median is gotten by deriving or looking for the middle value in a sorted data set. So what does this mean? This means that these are data sets we have here. This range of numbers is already sorted. Sorted means it's either arranged alphabetically or is arranged is either arranged in descending order or is arranged in ascending order. So ascending order from lowest to highest, from smallest to biggest. Then descending order is vice versa. So let's do something now. We'll clear all this value. Then we'll just write them randomly. 12, 14, 11, 13, 10. So 12, 14, 11, 13, 10. So I've arranged these numbers in a way that is not even sequential. I've arranged it in a way that is not sequential, but let's look at it now. So if you take notes, the formulas that we wrote here, so this formula here still calculates all the numbers together, right? It calculates the sum of all the numbers. Then this formula also counts the number of data points. Then this formula gives us the sum of all the numbers divided by the number of data points. So if you notice, it's still giving us 12. So what this means is that irrespective of how we arrange this range of these numbers, as long as it's still the same numbers, anyhow we arrange it, it means the mean would always be 12. So this tells us that 12 is a measure of central tendency for this particular data set using the mean technique. So if we were to use the median technique, so looking back at our notes, the median technique says the middle value in a sorted data set. The middle value in a sorted data set. So let's sort these data sets accordingly. So we'll do it in two ways. We'll sort it first in ascending order. So we'll sort it first in ascending order. Then we'll also sort it in descending order. So we're sorting both in ascending order and descending order. So let's do for descending order. Okay, let's do for ascending order. So 10, this is the smallest value. Then 11, 12, 12, 13, then 14. Take notes. So this is it in ascending order. Then let's do it in descending order. 14, 13, 12, 11, then 10. So if you notice a pattern here, you will see that both for the ascending and descending, 12 is a value that is very consistent. So when they were arranged when the values in the set was arranged in ascending order, right? 12 was still consistent at the middle. It was at the center. Then notice when it was also arranging descending, 12 was also consistent at the center. So it means that it's at the is a measure of the central tendency of this set. Taking note of this two, let me just give it a highlight here. So taking note of these two values here. So when this set, this original set we have here, right? The original set we have here, when they were arranged in either ascending or descending, there was a particular value at the center. So this is central tendency using a median, right? Using a median method or a median technique. So what this means is that this is just an example, right? An illustration, but irrespective of values you have, so you could take any value, any sequence of values. It could be 5, 5, 15, 30, 32. It could be like that. But once everything is arranged in a particular sequence, once everything is arranged in a particular sequence, maybe in ascending order or descending order, whatever appears at the middle, you will likely notice that if you calculate the average using the mean, right? If you calculate the central tendency using the mean, it will still be in the same range or the same value, exactly the same value actually, as if you use the median by arranging it in either ascending this order or descending order, then looking for the middle value. Yes, then there's one other thing to note. So this is one other thing with mean. So let's say we had another value here, 15. So we had another value 15, right? So is now how many values? So let's do our count again. A2 to A7. A2, yeah, is now 6 values. So let's update this also. A2 to A7 is now 6 values here. So it's now 75 as total. Then the number of data points is now 6. So this means that our mean would also still follow the same sequence. But during the calculation now, the new change is that our mean, our central tendency using mean is now at 12.5. It's now at 12.5. So since this is at 12.5, right? Since it's at 12.5, if we're to use the median, if we're to use the median using the same sequence, take note, we now have another value here. So we're adding 15 here. We're adding 15 here. Then for this one, we'll shift it downwards. Then 15 will stay at the top. 15 will stay at the top. So you notice something. You notice something. In these two values, we no longer have a perfect mid or middle number again, because before, when it was just 5 values, it was 12, right? It was 12, that was the mid number. It was 12, that was the mid number. But looking at this now, if we count 1, 2, 3, 4, 5, 6, right? So we no longer have a perfect mid number. So this means this now brings a rule. This now brings a rule when using median. So in a case whereby the numbers are perfectly even, so this means that the number of data points is perfectly even. That is an even number. In this context, 6. Remember, it was 5 before, of which 5 is an odd number. Yes. So if it's an odd number, at that point in time, you can find a perfect number situated at, or a number situated perfectly at the middle when everything is arranged in good sequence. Yes, but in a case whereby an even number, it means that you will have two numbers at the middle. So if we to count this, then look for the middle. We have 1, 2 here. We have 1, 2 here. And we have 1, 2 here. So the middle numbers here is 12 and 13. The middle numbers here are 12 and 13. The middle numbers here are 12 and 13. So the same thing in the ascending order, the descending order aspect also is 13 and 12. Still the same, just how they are arranged is just differently. How they are arranged is just differently. So when you get to instances like this, when you know that you're trying to use a median, right, then you have an even number. Yeah, so what you just need to do, you need to calculate the mean of the two numbers occurring at the middle. So in this context now, we have 12 and 13, right? They are the two numbers occurring at the middle. So if we calculate the mean, so this now means that 12 plus 13, then divided by the number of data points between these two numbers. So the data points between these two numbers in this context is just 2. So we'll now say 12 plus 13, 12 plus. So in this context, I don't want to reference, I just want to write the digits like that. 12 plus 13. So I'm locking them with a bracket, right? To follow the board mass sequence. Okay. Divided by 2. So this, take note, this is the formula in the box, right?
And we are not seeing your dashboard.
You can't see. Okay. Seems I was still sharing the. Okay, so let me take this back. So I have these numbers here. I added an extra value. We didn't originally have 15 in the data sets. We didn't originally have 15 in the sets. So I added 15. So this was an extra number. So this increased the count of the sets to 6 as opposed to 5 that it was originally. Then when we did the sum of all the values, it was 60 before, but now it now became 75. So this means this now increased uh, mean our mean value to 12.5 as opposed to 12 before it was 12, but now it now became 12.5. Yes. Then I was talking about how we no longer have a one just one number, a single value that is perfectly at the center when the values are arranged either in ascending order, when the numbers are arranged perfectly in ascending order or descending order. When the numbers are arranged perfectly in ascending order or descending order. So we no longer have one single value when these are arranged in ascending order or descending order, but rather we have two values that can be found at the center when the set is arranged in ascending order. So look at in ascending order, we have 1, 2, 1, 2, 1, 2 in ascending order. Then in descending order, we have this 2 here. This 1, 2, 1, 2, then 1, 2. So you will notice that in both ascending and descending order, in ascending order, the values at the middle were 2, and it was 12 and 13. Then in descending order, it was 13 and 12, which is still the same value. Yes, which is still the same value. But if it was to be 5 digits we have in this set, right, it would have just been 12 that would have been occurring at the center. Yes, so I'm giving you a rule when using the median technique, right? Because the median technique says you have to sort the values in either an ascending order or it could be in descending order. Then any value in the list you find at the middle, perfectly at the middle, you now know that because if it's 5 values, you know that 2 will be on the left side, then 2 will be on the right side, then 1, if it's 5, right, 1, 2 on the left side, then 3 would appear at the middle, then 4, 5 will be on the right side. Yes, so at that point in time, 3 is perfectly at the middle. But if it's what if it was 1, 2, 3, 4, 5, 6? You now know that both 1, 2, 3, 4, 5, 6. So 3 and 4 is now appearing at the middle. So it's two values at the middle. So when it comes to those points in time, and you notice that it's mostly when it's the numbers of data point is an even number, that's when you have two values in the center of that particular range when it has been arranged. Yes. So when you get to that scenario, you don't just get to choose any of them. No. Rather, you calculate the mean of the two values appearing at the center. So in this context, it's 12 and 13 appearing at the center of this list when it has been arranged or when it has been sorted. Yeah, so we now, if we now have to calculate the mean, right? So that means it's now be, so using our equal to prompt, right? 12 plus 13. Since we'll be dividing with another value, so this means we'll just add this in a bracket. So it will be calculated first before it does the division. So divide by, so the number of data points for these two. So this 12 and 13 becomes a data point at this point now. Yes, so it's just two values in this data point. So 12 plus 13 will now be the sum. The number of data points is 2, 12 and 13. So that's two values. So if we calculate it now, you now notice that we now have the same mean we had again. So we now have the same mean we had again when we use the mean formula, right, to calculate when we use the mean formula to calculate the average. So now using the median exception, we now fall back to the same 12.5 again. But this time around, we had an even number for the number of data points. But if it was when we had an odd number, if it was just 5, right, we knew that it was 12 that was the measure of central tendency. But when it became an even number, it means that we had an exception to how we were supposed to calculate the mean. So if the number is an even number, if the number of values in a set turns out to be an even number, 10, 12, 14, 6, 4, and all those. Yes, if it turns out to be an even number like that, you arrange it in a sequential order, be it ascending or be it descending. Then any numbers you find at the middle, it will normally be two numbers. Yeah, since it's not an odd number, you find two numbers at the middle. So calculate the mean of those two numbers you find at the middle after arranging it. So that will give you your median at that point in time. Then you will now notice that the median will still correlate with the mean if you use the mean formula. So in this box here, in this cell here, we use the mean formula. What we just did was basically, so let me just write this in a more direct term. Let me write this in a more direct term. So we did some A2 to 6, then divided by counts A. So if I was to write this as, okay, I think this is 7, not 6. Not 6. So I'll correct this one to 7. So if I were to write this in one formula, this is how it actually is, but I just have to break it down so we would all understand it. So this is actually the formula to calculate the median in this context. Yes, the median in this context in a way that is still detailing the formula. But if I just want to calculate it generally, I will have a function for that too. So we have the average function. Yes, so let's try the average function now. A2 average A2 to A7. Here you see all through these formulas, I use different method to calculate it, but you notice that we're still ending at the same value. We're still ending at the same value. So it's still 12.5, 12.5, 12.5. So that means the measures of central tendency is correct. Then there's also one other measure of central tendency, and this measure is the mode. Yes, this measure is the mode. And using the principle of the mode, it says the mode is the most frequently occurring value in a set. Yes, so this is where it becomes tricky. The mode is the most frequently occurring value in a set. So this now brings me up to this point where I have to kind of like give um, a rule of thumb. Yes, I'll call it a rule of thumb, kind of like a best practice. So while all these different techniques are all used to find or calculate the measures of central tendency, right? While all these techniques are all used to calculate the measures of central tendency, there are certain of these techniques that are to be used in a particular context. Yes, there are certain of these techniques that are to be used in a particular context. Then some will be used in other contexts. So in particular, the mode, in particular the mode. So the mode is mostly used when you're dealing with a value, a range, or a data set that has recurring values. Yes, you're dealing with a data set that has recurring values. So the values are recurring, meaning that, for example, okay, let's do something practical for that one. Let's do something practical for mode. So these ones, this example here above, right, is for both mean and median. So let's do something for mode. So we have a list of values, numbers. So let me create another data set. We have numbers, and we have four. And we have four again. Then we have three. Then we have six. And we have nine. We have nine again. We have nine. So let's assume that. Let me just make this more. Um, let me make this more practical, right? Let's assume that this were to be like the score for students in a test, right? So students wrote the test, then this were their score. So this person is one student, then this person is another. This person is another student. 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 So at this point we have seven students here. We have seven students here, right? So we have seven students, and these are their scores. So different students. So the first two students had the same, scored the same in the tests. So let's say they did over 10 and so on and so forth. Yeah. So this student scored this value. This student scored this value. Then these three students were like this last 3 year were like the best performing. Yes. So using the principles of mode, using the principle of mode, saying the most frequently occurring value in a data set, the most frequently occurring value in a data set,
This is 9.
exactly, is 9. So the most frequently occurring value in this context. So the mode now becomes 9 in this context. So basically what mode is used for is for especially context like this. Yes, it's for context like this. So if we were to say, if somebody asked, yeah, what's the general um yeah, what's the general performance of the students? What's the general performance of the students? If we were to look it in terms of quantity, maybe the ideally, right? If we're to say for every seven students, what's the likelihood of one scoring? Kind of like trying to relate it to probability, but not necessarily probability. Yes, what the likelihood of any student scoring 9? Yes, scoring 9 or scoring 10. If you know that first, it was just two students that scored 4. Then it was just one student that scored 3. Then it was just one student that scored 6. So take notes. It was just one person that scored 3. It was just it was just one person that scored 6. Then it was two people that scored 4. Meaning that then it was three people scoring 9. Meaning that if three people can score 9, it means that if we were to increase the number of these students again, maybe if they are to have more students to join them, for these students here to score 9 and they're like three of them scored 9, it means the likelihood of other students scoring 9 too is also as high as this particular likelihood in this particular context. So that's basically what mode is. That's basically what mode is. Then another simple example I'll give you is if you go to, let's say you go to a party, right? Maybe the party was said to be like an all white party, right? All white, mean that that's like the dress scheme. Yeah, so entering the party, you saw that maybe you're still at the gates, you've not yet entered the venue of the main party, but in the gates, you just saw 10 people, right? You've just seen 10 people, but about six of them were putting on whites. Yes, they were putting on whites, up and down white. Then you saw one putting on maybe a black shirt. Then you saw two people um putting on maybe gray shirts. Then later on you got to find out that they are part of the catering service for the events, right? So six people are putting on white, one person was on black, then two people putting on a gray shirt were part of the catering service. Then you saw one other person putting on brown. Yeah, so what, just because you've seen people wearing otherwise, it doesn't mean that if you go inside, it should reduce your expectations of the people that might be wearing whites. Yes, because just from the small sample, so the first 10 people you saw at the gate was like a sample of the actual population you might actually experience when you get into the venue. So even when you experience the sample at the gates, you saw that in that context, just within that small sample size, right? You saw that if people putting on white were still up to six. So at that point, six is like the mode. So white shirts is the mode. So it means that when it gets in there, you'd likely see more and more people putting on white. Then another example is if somebody says um, Nigerians are mostly black in complexion, right? Yes, that can also be represented as a mode because if we were to count every single Nigerian, then lists that each individual's skin complexion, you see that black would be occurring most frequently. So at that point in time, it's also mode. So while mode might not be very similar in technique with mean and median, right? It also gives a grass or a crude, yes, I'll call it a crude representation, a very rough representation of what might be the central tendencies. So remember, the goal of the central tendency in the first place is to provide one value that might be a likely estimation of every other values that might not be known. Yes, that might not be known sometimes in a data set, in a set. Yes, one value. So what are the importance of this? The importance of these are in contexts whereby let's say certain provisions, maybe somebody offered scholarship, right? Or somebody decided to fund the provision of school uniforms to children in the secondary school or across multiple secondary schools. Yes. So the person offered that, okay, I would make these uniforms, right? Then I would distribute it. But in order for that to be done effectively, it would be nice if that person goes to these schools, then collects data about the height of the students in each classes. So for GS1, what's the height of the students? What can be represented as the basic? So we know that there might be some people that will be taller, there might be some people that will be shorter, but at central representation, what is one height or what is that estimate that we can use that, okay, even if there are some people that are shorter, even if there are some people that are shorter, that uniform will just be bogus in their body. But even if there are people that are taller, it might be a little bit tight for them, right? But the majority of the other people, it will fit perfectly. Yes, so in that context, this is where things like measures of central tendency comes in. So this is just one basic example, right? This is just one basic example. So if they were to go and do that now, that means they would have to go and calculate the average height of students in GS1. Then they will sew the uniform according to that height. Maybe if they will add allowance, they might do that. Then do the average for people in two, do the average for people in three, and so on and so forth. Then another example is if a car dealership, right? If a car dealership decides to expand into this region now, right? I think in their research, in their market research, they might just want to know amongst the different car owners or vehicle owners, which brand of cars or which make and model of cars do they drive the most. So if they were to collect such data, right, they will notice that in their lists, in their sets, in their data sets, right, Toyota might be very common. So at that point in time, Toyota becomes the mode. Yes, Toyota becomes the mode because if you were to even do a rough experiment for that, just go to any road where vehicles usually pass and start using your eyes to count the make of cars you see. You will notice that maybe if you were to see 20 cars, Toyota might occur more than the other brands you will see. Yes, so in that point in time, it still goes in line with mood. So Toyota now becomes like a measure of central tendency in that context using the mode technique. So these are how these measures of central tendency are mostly used. It's very applicable in our everyday life. Yes, then not just our everyday life, it's also very much applicable when engaging in certain data analytics efforts, right? Certain data analytics efforts for it could be even for basic financial accounting and certain things like that. For one other example again, maybe you want to go for shopping, right? To just change your wardrobe or do certain stuff. Yeah, so even before you go, you can just decide that okay, I'll be doing this shopping in Bayelsa here, but let me just go to Jumia to just check for price of things that I might want to buy. Go to Jumia, go to Konga, right? Then you just check for the price of certain watches, shoes, and things like that. Yes, you might just decide that okay, let me compare and contrast from these different platforms, and I'll just calculate the average. Maybe calculate the average, then I'll use this as a base for my estimation because I don't actually know what I'll be seeing when I actually go outside to shops in Bayelsa to actually go to buy those items. But let me just estimate it to be this way. Yeah, so that's also another way where people usually use the measures of central tendency in their everyday life. So mean, median, and mode are the measures of central tendency. So that's something to take note of. Then we also have what's called the standard deviation. The standard deviation. So this is a term that might not be very common. It's a term that might not be very common. Most times people might have heard of mean, average, even median. But standard deviation is also another term that is also statistical concepts, also used, yes, even used by data analysts, right? So what this one does is that it measures how much data points deviate from the mean. Yes, so remember I said the mean is used to get or calculate a single value that might be used to represent every other value in a set, kind of like an estimation, a center value that can be used to represent every other value in a set, or can be used to estimate the outcome of every other value in a set. So that's what the mean do. But standard deviation now is saying, okay, even if there's a center value, right? Yes, standard deviation is trying to know how different the other values in the set might be or is from the center value. Yeah, so we have um, range of values, right? Okay, let me make this. Let me take this to the screen again. I think it's best to describe it this way. So let's change the context of this same data I have here. Let's just change the context. So let's say this was this became this becomes the WAEC results, right? Of these students. Becomes the WAEC results of these students. So I'll just give a rough sketch, right? So this person did 300. This person did 295. This person did 299. This person did 120. This person did 105. This person did 203. This person did 95. Yes. So even in this range, right? Even in this range, it's known that we can also get the mean value. It's still very possible to get the mean value. All we just need to do is to calculate the mean. Once we calculate the mean, we'll be able to get the mean value. Yes. So we can decide I want to calculate the mean using the average formula, right? Then we'll say B11. Okay. B B11. Hold on. So B11 to B17. So at this point in time, this is what's being shown, right? This is what's being shown as our average. So we see that it's not actually a whole number, it's a number with some decimal places, yes. But this is basically what's shown as the average performance of the average score of students in this particular list, saying 202. So if we were to round this, that it's 202, right? So we were to round it down, it's 202. Yeah, so this is what this is saying as the average performance of students in this particular examination for all these students, right? The WAEC results of all these students. Yes, but this is just mean. This is just mean. This is what mean is telling us. Mean just tells us this. Then what about standard deviation? Standard deviation. So what's standard deviation? Standard deviation is trying to tell us, okay, even if this might be a mean, for each of these numbers here, what was the difference? What was the distance for each of these numbers between the mean? So what was the distance between 300 and this 202 here? What was the distance between 295 and 202? What was the distance between 299 and 202? What was the distance between 120 and 202? What was the distance between 105 and 202? What was the distance between 203 and 202? What was the distance between 95 and 202? So that's one thing to note with measures of central tendency. While they can kind of give you a broad representation of the values in a particular set, there are certain times that they might not actually tell a particular story, or they might not actually give you a particular insight. Yes, because if we were to just look at this list and see the average in a particular context, right? To see the average um, score of this student is 200. Let's say this was a good score, right? To be an average. Yes. Let's say this was a good score to be an average, right? Yes. Then there might be sometimes that okay, what if this guy scored 95 here? Then this other person scored okay, this person scored 60. Then this person scored, let's say 400. This person scored 395 also. Okay, let me also take this down. So this person scored 50. This person scored this person scored 77. Then this person scored 320. Okay, let me make it in this context. Let me make it 350. Yes. So take note of these values here. Three people scored above 300. Then the remaining people scored below 100. Yes, many people. So in the case of an educational institution, right? In the case of an educational institution, the education of the student is more important than just numbers. Yes, but if this the educational institution was to just assume that based on these numbers, right? Based on these numbers, okay, 200 is a good average for you students. But if you come back to this list, looking at it one by one, you see that it was only three students that had very high scores, but the rest had were doing very poor, which is that they were below 100. Yeah, so that's one thing with mean. It might try to give you what that's one thing with measures of central tendency. They might try to give you what is a broad representation or estimation of values in a set, but they might not actually tell the differences all of the values in the set might be. Yes, they might not actually tell the differences all of the values in the set might be from the mean or the said mean or average value. So that's one thing to note. But standard deviation kind of tells you a story. It gives you that insight or that perspective that okay, even if this is the average, but these are other values were in comparison to this average. Yes, that's basically what this means. That's basically what standard deviation does. It tries to gives you that perspective how other numbers are in relation to that number you're trying to figure out the mean. So why is this actually something to be considerate of or to be considered rather? Yes, why is this something to be considered? If I go back to the example, where somebody wanted to sew school uniforms, right? For somebody wanted to make school uniforms for students in secondary school for GS1, GS2, GS3. Yes. So if that person that wanted to make those uniforms in those classes, maybe in GS1, there were like 5 students that were outrageously taller than the other students. Yes. If when they were taking the measurements, they accounted for those 5 students that were outrageously taller than the other students, it means that by when the uniform would have been sewn, it wouldn't have fit in the average students in that class. Yes, it won't even fit the taller students too. Yes, because in a range of numbers in a set, higher values, there's a concept called outlier. There's a concept called outlier. So an outlier is a value that is very uncommon in the sequence of all the values in a set, meaning that it's not very likely to occur again in the sequence of a set. So I remember our subsequent classes, I used an examples of maybe sales for a supermarket where the supermarket usually grows between 5 million, 7 million every month. Then there was a particular month where they just gross 150 million. Yes. So there might be somebody that came there to purchase something, or maybe it was during a certain holiday period whereby everybody was just buying stuff, right? So that's why it increased the sales of that company to that point. Yes, but at that point in time, that particular sales is an outlier because it's unlikely it's unlikely to repeat itself again. It's unlikely to repeat itself again in the sequence of the sales for that company. So that's basically what outliers are. That's basically what outliers are. So that's one thing to take note of, why standard deviation. So if you, even if you get an average when trying to make certain analysis or trying to make calculation, is also a good thing. It's also a good thing to want to see the standard deviation also. It's also a good thing to want to see the standard deviation also for a range of values. So for this one now, let's check the standard deviation. So we use the standard deviation formula. Okay. Okay. So we use the standard deviation formula, then we reference our range, which says B11 to B17, if I'm not mistaken. B11 to B17. So, so this is what is giving us now. So it's saying that the average numbers here, the average numbers in this list here, this list, I'm about to highlight this list. The average numbers in this list is 100, and all of the numbers rather at average is 167 units different from the mean. So that's basically what this is telling us. The average number here is 167 units different from the mean. So why there might be numbers, right? Why there might be numbers that are actually close to the mean, if we actually start calculating the difference between all these numbers and the mean. Yes, calculating. So there is actually a statistical formula for standard deviation, right? Yes, but this is basically the essence of standard deviation. It tries to give you that. It tries to give you that perspective of how different numbers in the set would be from the mean number or from the average number. So that's something to take note. So in this context, this is now showing us. So there's a principle, since the essence of standard deviation is to try to show you how different all the numbers in the set might be from the average, right? So this now means that the higher the standard deviation value, the more varied. Varied means that the numbers are not closely, the numbers are not close to each other in order of the quantification. That's the measurements are not close to each other. For example, 2, 5, 3. 2, 5, 3, 75, 6. So let me write this down. 2, 5, 3, 75, 6. So these five values, right, in this set. We have five values in this set, but 2 is very close to 5. 5 is very close to, it's a bit close to 3. This is a bit close to 6. But 7, none of these numbers are very close. 75 rather, none of these numbers are that much close to 75. So at this point again, 75 is also an outlier. That's one thing. 75 is also an outlier, but to buttress this point again, let's calculate the mean. Let's calculate the mean of these values, then let's calculate the standard deviation again. So average F2, okay, F11 rather, F11 to F15. F11 to F15. So we're having 18.5. Then let's do the standard deviation. F11 to F15. The standard deviation is 31. So the average value here, the average of this value is 18, of which, if we can see that if we were to use median to calculate this, we don't even have a value. You don't have a value that would sit at the middle that will be 18. Yeah, so this is one thing that outliers do to numbers in a set. When an outlier occurs, it skews the average or the measures of central tendency of all those values to either a very rightwards distance or a very rightward side or a leftward side. So if the values, if the outlier is way lower, sometimes so yes, it happens as such. Then if it's the outlier is very high, it also skews it to the right side of the graph. Yes, but a perfect, okay, let me check this. So I want to do a bit of show you guys an image. Okay, so let me just share this image. So I have an image here that basically explains measures of central tendency. Yes, so the one at the middle, if you look at it, this is a graph. This is a graph I'm talking about. This is a graph, this is a y, this is a x, yeah. So if all the numbers in a set are closely related together, by the time you calculate the average, you would have a bell shape like this. It will be perfectly, the central tendency will be perfectly at the middle. So what this means is that the mean, the median, and the mode will most times be very close to each other. Sometimes it might even be the same. Yes, sometimes it might even be the same. So that's what this means. Then if we have, like, for example, the example of these values I just gave now, 2, 5, 3, 7, 2, 5, 3, 75, and 6. Yes, if this was to be represented in this graph, we would have a shape like this. Would have a shape like this. Yes, the negatively skewed shape. So it's not a perfect bell shape. This one looks like a bell that is placed on a desk. It looks perfectly like a bell that is placed on a desk. Then if most of the values are on the low end, but we have some very, very high values also, then we have a positively skewed bell shape. But a perfect bell shape would be when the values are very close to each other. So an example of range of values that would have a perfect bell shape is 12, 13, 15, 11, then let's say 14. Yes, so if we were to calculate the average, the measures of central tendency for such a data set, we would have a perfect symmetric shape like this. It means the mean, the median, and the mode would most likely be close to each other. They will most likely be close to each other like this. Yeah, so that's something to take note of. So while most times you can use average, you can use mean to try to calculate the estimation of all values in a particular set. So the set could be things like performance scores of students in a school. The set could also be your sales record in your supermarket or your shop. This set could also be the revenue you've generated so far for your consulting business. Yes, a data set can mean anything for different industries. Yes, but you now know that, okay, as long as it's a set, a data set, and once you have numerical values to it, most times in your analytics, you might want to imbibe certain um, statistical approaches like this when doing your analysis. So understanding the fundamentals of this um, statistical efforts is very, very important. So we'll go back to the notes. So we say standard deviation measures how much each data point deviates from the mean. So statistically, this is the formula. So the one below here, this is statistical formula. It might seem confusing. These are scientific notations. So basically, what this means is that the standard deviation is the square root of the difference between each data point and the mean, right? As opposed to divided by the number of data points. Yes, so that's basically what this means. So where xi in this formula here means each data points. So xi in this formula means each data points is xi. Then this is the mean. Then the capital N is our number of data points. Yes. So this one good thing about when we learned introduction to digital tools. Yes. So if there weren't digital tools, imagine you would have known how to actually solve all this mathematically. But through digital tools like Excel, now you saw how I did this. I just used the standard deviation formula. So I didn't actually even need to know. I didn't need to know all those scientific notations, how to write all those scientific notations. Yes, so that's one of the advantages, the great advantages of using digital tools for analysis. If not, I would have had to know how to use all those, understand all those notation, how to do this one, how to do that one. I would have need to understand all this syntax that are here. Yeah, but going downwards, you see that a low standard deviation tells you that data points, all the data points are close to the mean. Yes, a low standard deviation. After calculating your standard deviation, if you have a very low value, it means that all the range of values there are close to the mean. So let's try this one now. So if you notice when we did the standard deviation for the students, this WAEC results, yeah, the standard deviation was very high. Then I say that it was because the value is telling us, what this story is telling us, that the values here are very far from what the mean might be. But let me give you another instance now. So let me still copy this. Okay, let me copy this and add it here again. Okay, so but this time around I'll change the values. So I'll make this one 355, 350. Then I'll make this one 357. Then I'll make this one 360. Then I'll make this one 300. Then I'll make this one 346. Then I'll make this one 390. Then I'll make this one 378. Yes, so if I do it like this, so you now see all these students now in this context had a grade within between 200 during 300 and 400. Then if you look now, look right over there, you see that the standard deviation is now becoming lower. The standard deviation is now lower than the average. The average now is, the mean is very close. It's a close representation to all the values here. The mean is around 350 something. Then if you check all the values here, we have values like 350, which is close to 350 something. We have values like 357, which is close. We have value like 360, just 6 units difference. We have value like 300, which is just 50 something, 55, 54 units difference. We have values like 356, right, which is also very close, 390, some unit difference, and so on. Yes, then if, let me use smaller values now, this will be much more easier. So let me do 12, 14, 12, 15, 16, 13, 11. So take a look at this now. Our mean is now at 13. Our mean is now at 13, meaning that the one single value that will best represent all these values in this range is now 13. Then if you take a look at our standard deviation, is now very low, is at 1.7. So this means that when values in a set are very close to each other, it means that if you get the mean from those values, that mean is a perfect representation of all the other values in the set. So even if there might be some differences, right? There might be some differences. Some people might be some units, some values might be some unit different from that estimation you're having, but it means that it's very close to each other. So for every time you're calculating average, right, if you have outliers, that might skew the representation of what that average is representing. So this means that your standard deviation is a good way to check Yes, a good way to check. So ideally, the lower the standard deviation after getting an average, the closer those numbers can be represented by that average or that central tendency. That's what this means. Yes, then the higher the standard deviation value, it means that okay, even if you could have gotten the average or you could have gotten the central tendency, but it's telling you that these numbers are still varied from each other. Or yes, they are still varied from they are still varied, rather they are still varied from the mean, mean that the mean doesn't do so much justice. Even if it's the mean is trying its best to do justice to them, but it doesn't do that much justice. Yes, it doesn't do that much justice to them. So if this were to be the height of students, let's say this was in centimeters. Let me change this now. Okay. I don't think this is supposed to be in centimeters. So let's just assume any units, right? Let's just assume any units, but this were to be height of students, right? This were to be height of students. So at that point, we had a student at height 12. We had a student at height 12. Then we had a student at height 14. I said that's height 12 again, height 15, height 16, height 13, height 11, just like that. Yes. So this means that if we were to sew uniform according to this average, based on what this the mean is telling us and what the standard deviation is very low, meaning that the data points are very close to the mean. So if we were to sew a uniform that is at 13, maybe let me use centimeters. Yeah, let me use centimeters for instance. If we were to sew a uniform that was at 13 centimeter, right? So uniform that was at 13 centimeter, you know that it would fit almost all the students in that class. It will fit almost all the students. Yeah, so this is what this is telling us. It will fit almost all the students. Then going back to the WAEC results here now, right? The mean score of these students was at 203. If we were to assume that this is a good grade, right? Yes, if we were to assume that this is a good grade, so let's assume this is a good grade, then the standard deviation is 167. So if the school management was were to announce that our students, based on the fact that the mean was at 203, if the management were to just use this to announce that our students performed very well in this year's WAEC examinations, yes, that wouldn't actually do justice to the reality, because our standard deviation is telling us, giving us kind of like an interpretation or perspective to the reality, which is that our standard deviation has a very high value. That's a very high value, meaning that it's telling us that the most of the students here, their score is actually kind of very far from what this what this mean measures of central tendency is telling us. Yes, their score is kind of high from what this measures of central tendency is telling us. So even if this measures of central tendency is trying its best to give us that, but this is what it looks like. Oh, okay, so if the school were to make use of this information, we'll now tell them that okay, this is the average of these students, but majority of them didn't actually perform like this. Yes, because the standard deviation is high, is very far from the mean value. So what this school needs to do is that they need to ensure that in the next examination cycle, right, all the students are properly educated and enlightened and prepare ahead of the examination. So that's one thing to take note about for standard deviation. It measures how much data points deviate from the mean value. So how do you get to, after learning how to do this analysis, so take notes. After learning how to do this analysis, how do you get to interpret it now? How do you get to interpret it? So after learning, okay, Okay, so before we get here, right, let's just go back to this. Let's just go back to this. So for each of these formula, each of these techniques, mean, median, mode, and standard deviation. Yes, digital spreadsheet tools like Excel and Google Sheets actually provides formulas. So you don't actually need to start doing calculation for all this, but you actually have formulas to use to calculate them. So let me just write this accordingly. So I'll just show you, I'll just show you the formulas. So for mean, take notes, the formula for mean is written as average because mean and average is still the same. Or rather, most times people know mean as average, but it's representing the same thing. So G11 to G17. So this was average. So we use the average function. So average, open brackets, the cell range. So that's where cell referencing comes in. You need to know the reference of the cell, like we learned in the previous classes. So once you know the reference of the cell, if you want to reference multiple cell, you now know that G11 to is represented as a column. G11 colon G17. That means G11 to G17. Then for median, the function for median is median. Yes, is median. So G11 to G17. Then for mode, the function for mode in digital tool is still mode. Yes, G11 to G17. Then standard deviation, the function is STDEV. Take note, STDEV is just kind of like a short representation of the full phrase standard deviation. So you need to know the range also, then you reference it. So these are all you need to take note of for how to use these functions, these statistical functions in a digital spreadsheet software like Excel or Google Sheets. Yes, so it's only average, it's only mean that is using a different name. It's only the mean technique that is using a different name, which is average. The median, to write a median equation, you just write median equal to, remember, you always need to start with your equal to prompt because using your equal to prompts is letting the spreadsheet software know that you're about to impute a logical or a mathematical operation. So it makes it, remember, by default, the cells are just designed to enter in data. They're just designed to enter in data. Yes, but it's only when you impute an equal to symbol that you're telling it that, okay, you want to make a calculation. So that's when it gets into that logical or mathematical mode to know how to make these calculations. Yes. So back to interpreting results. So how do you get to use these things to actually interpret results and make meaning of your analysis? So how do you get to do this? You do this by using mean to find the average. Yes, you use mean to find the average. You use mean to find the average. So mean is mostly, take notes, mean is mostly used to find the average, but it is affected by outliers. So mean by default is the go-to technique to find the average, but it is affected by outliers. So if you have a range of values, if you have a set, if you have a data set, by default, you want to use mean to get the representation of all the values. So if you have sales, if a business had sales for the different months, if by the end of the year they want to calculate the actual income for the end of the year and do all those financial account statements, right? Yes, by default they would say the average month by month sales was. Then they will now use the main formula to calculate that. Yes, but if there were to be outliers in any of the months, it means that that outlier would actually affect the value of the mean because it will skew it. So remember the charts. Remember the chart I shared with us. Remember the chart I showed to us. That outlier would actually skew it in this kind of way, in a way that is kind of negative, negatively skewed. So it is skew it. So that's something to take note of for the mean. That's something to take note of for the mean. Then for median, is best used when you've actually used mean. Yes, it's best used when you've actually used mean to when you've used mean to try to get your average, right? But you actually got to find out that there are outliers. Yes, we actually gotten to find out that there are outliers in the data sets. Yes, we've actually gotten to find out there are outliers in the data set. So median would most times try to represent the middle value irrespective of the outlier. Because if you remember how median worked, we just had to arrange all the numbers in either ascending order or descending order, but we just had to sort it, right? Then we just collected the number at the middle. Yeah, so by default, you should know that you're using average or mean. Yes, but if the data is affected by outlier, you now know that you're to go to median to find it as an option. Remember, we have three central measures of central tendency. So what this means that there are situations where you would use mean. Yes, it's also most times by default. Then there are situations where you use median, like you use median now, like in this context I'm giving now, you use median when you found out that the data is actually skewed, meaning that it has outliers that would actually skew the direction of the central tendency. Yes, so it best represents the middle value in a situation where the data is skewed. Then for mode, use mode when you're trying to see the most occurrence. So you're not just trying to see like um, a calculated value, a calculated central tendency, but it's more of a frequency thing. Yes, it's more of a frequency thing. Like, okay, you were asked how many people scored A on this test. Okay, no, let me use a number. How many people scored 100 over 100? Yes, how many people scored 100 over 100 in the test or the exam? Yes, in that point in time now, you're not actually wanting to just plus all those numbers together to give you a value, but you want to just get a sequence or a frequency of performance for all of the number categories that might occur in that particular class or class data set. So in that context, you use a mode. You use a mode. So it shows you the measures of central tendency in regards to the most occurring values in the sets. So, like the example I still gave again for the party, the all white party, whereby people wearing whites would be the majority, or people wearing whites would be the measures of central tendency, because people wearing whites to an all white party are more likely to be observed than people wearing black or any other color. So, that's something to take note of when using mode. So you use mode when you're trying to actually see the most occurring values in a set. Yes, and not necessarily to just calculate a best estimation. So even if it still estimates, right, what will be the likely value to occur next, even in unknown situations, it doesn't actually have to sum them and divide the average for them most of the times. Yeah, so that's something to take note of for mode. Then standard deviation. Standard deviation gives you an interpretation, or it tells you a story as regards to the performance of the measures of central tendency. So, like I said, if after calculating your standard deviation, you see that you have a low standard deviation, it means that the difference in the numbers are very consistent. Yes, the difference in all the numbers in respect to the mean or the central tendency is very consistent. Consistent means that it doesn't change. Yes, it's in a range that is very closely linked to each other. So there is no much variation between all the numbers. Yes, then if the standard deviation is very high, then it means that there is too much variability. So variability, variance, so is a statistical term called variance. So variance means how different, what's the gap each numbers have from each other. Yes, what's the gap each numbers has from each other? That's basically what variance is. So in the context of this WAEC result scores, right? So variance would be what's the difference between 400 to 395? What's the difference between 395 to 350? What's the difference between 350 to 77? What's the difference between 77 to 50? What's the difference between 60 to 50? What's the difference between 95? But basically, each of these numbers, what's the difference between each of these numbers to every other number in the set? Yeah, so what is the difference between 95 to 60? What is the difference between 60 to 95? What is the difference between 50 to 60? What's the difference between 60 to 77? And so on and so forth, like that. That's basically what variance means. Yes, that's so numbers, a set with a low variance means that the numbers are very close to each other. Yes, that's what it means. Set with low numbers, variance tells you that the values in the set are very close to each other, meaning that they can be properly estimated. So even if we have unknown sequence, so if we, let's say, let me use a practical example again, um, still relating to the um, school uniform measurements, right, for the students. Yes. So if after getting, maybe there were 30 students in the class, right? 30 students in the class. Then if after calculating their mean height, right? We took all the height, they will calculate it. Then their mean height was 75 centimeter. Then when we checked the standard deviation was at 0.7 or 1.2. That means the standard deviation is very low. So what that means is that all the height of the children are closely linked to each other, which might be possible because if they are of the same age, most times the average people or average children of the same age might have heights very close to each other. Just some few that might be taller than the others. Yes. So that means that if we currently have 30 students and we have a very low standard deviation for the height, and we already know that um, mean their mean height is 75, right? If 10 new students were to join in the next academic session, yes, in the next academic session, there's a likelihood that those 10 new students, right, would also be in a height that is very close to these other students. So even if there might be outliers, the outliers will be very few. But this one thing about estimation. If most of the students in this particular heights, if most of the students in this class had this particular height, it means that more students that will be coming, yes, we could just sew a pre-custom made uniform for them, then they would actually fall between. So the uniform might be a bit tight for the ones that doesn't fit perfectly in that central tendency, or it might be a bit bogus, but it will still actually fit them. Yes, so those are actually use cases. Then another use case is also when you know that usually when you go to buy items in the markets, right? Maybe you're a trader, you usually go to buy items in the markets. What you usually go to buy for the past 5 months, when you've been buying it, your budget was 500,000. Yes. So you know that okay, this time around you want to go to the market again. So even if you know that things might have increased, right? Things might have increased or things might have been cheaper, but you know that based on basic economic principles, you know that okay, even if there might be some variation, it won't be that much. You won't go to the market and hear that, okay, something you usually buy around 500,000, they will just tell you that it's 1.5 million. Yes, so no matter how bad the economy might be surprising to us, yes, especially in this our current experience, right? Yes, but most times there would hardly be a situation whereby something you usually buy around 500 and something thousand to 500,000, then you just go to the market this time, then you see it to be 1.5 million or 2 million. Yes, so that's one other example of measurement of central tendency. So the reason why we actually go to the market, maybe we want to go and buy a new phone pouch, then we go with sometimes 2,000 or so, is because our brain is actually calculating the mean from the other times we bought it before, and our friends that had also bought it. We're just calculating that okay, this is a measure of central tendency. So we actually have a data set. The few times we bought it before are values in our data sets in our brain. Then the friends that have bought it or family that have bought it also, then they told us the price. We actually now add it and say that okay, this thing no go actually pass 2,000. So okay, might just carry too far, go increase safe. Yes, so that's something about one importance of measures of central tendency. That's one importance of the measures of central tendency. So it makes us to do things like this and makes us to do it in a way that is very efficient. Yeah, so getting to learn how to relate this to our everyday life is very important as attitude. Also help increase our understanding of things and make our knowledge and application of this very easy. Okay, so these are example problems I have here. These are example problems I have. Okay. So these are example problems I have here. So this for everybody. This is like a practical session. So looking at these example problems based on what we've learned so far. So the first example problem is saying find the mean, median, and mode between these values 5, 7, 7, 9, and 12. Then the second one is saying calculate the standard deviation. Yeah, so this for you now. This for all of you. So based on what we've learned so far and how we've done it for the other examples, so I want you now to instruct me on how to calculate the mean, median, and mode for these values here. So what I'll do now, I will input the values in my spreadsheet. So it said 5, 5, 7, 7, 9, 12. So 5, 7, 7, 9, 12. 5, 7, 7, 9, 12. 5, 7, 7, 9, 12. Yes. So the mean, median, mode. So based on these numbers here, so I want you to unmute your mic. You can unmute your mic, then give me an instruction on how to get the mean for this data set. Then anybody can contribute to for the median and also for the mode. Who would like to try, Mr. George?
Um, for the
Would you like
mean,
to give us a try?
yeah, for the mean, I want you to sum all the number of data points.
For media. So even if you might not be very familiar with the function, right? The function we might have used before, but I believe you maybe can just mention the concepts on how to go about it. Then I will just impute the function, so that way we also get to learn.
Okay. You now use the equal sign, I think so. Then you now say from A1 to A3, then divided by
Okay.
the data points, the number of data points, which is 3. Is it 3? No, it's not 3. It's about 5. Though I don't really know the commands from the data sheet, so,
Okay.
but I think that's it.
So if we wanted to calculate the mean based on this value, so we impute our equal to symbol. So we say to a mean. To calculate mean, we need to sum all the data points in the range in the sets together, right?
Yeah.
divided by the number of data points. So the number of data points, let's count: one, two, three, four, five. So we have five number of data points. Then the sum of all the data points. So if we wanted to sum this, so let's just sum it. So sum A2 to A, okay, sum A1 to A5, if I'm not mistaken. So it's 40. Then divide by counts. Although this is not how to actually do it, right? This is just me breaking it down. Count
Yeah.
A1 to A5. So it's telling us that our mean is 8. So let's check it using the mean, the average function. So A1 to A5. Yeah, so this is actually how to get the mean using a spreadsheet software like Excel or Google Sheets. So you use average equal to average, open brackets, A1, which is your range, right? The cell addresses of these data points you have here. A1, then a column, which is representing 2, column A5, then you close your brackets. So it will now give you the average. So you can also try this with your phone calculator. Yes, in case you want to experiment to confirm, you can try this. So you sum all the values here: 5 plus 7 plus 7 plus 9 plus 12 equal to, so whatever value it gives you when you impute or equal to, then you divide it by 5. 1, 2, 3, 4, 5. You divide it by 5, you see that is 8. Then for median, equal to median, A1 to A5. So this is how to get our median. Then modes, you write your mode function name. Then A1 to A5. Yes. So you see that our mode, this is a very centralized data set, because most of the values are actually close to each other. So you see that our mode here is actually 7, our median is 7, then our mean is 8. So the difference between all these values here is just 1 unit. Between 7 and 8 is just 1 unit. It means that it's very closely linked or close to each other. So the second example task was asking us to calculate the standard deviation between the data sets, between values in data sets 4, 8, 6, 5, and 10. So let's do that now. 4, 8, 6, 5, and 10. 4, 8, 6, 5, and 10. 4, 8, 6, 5, and 10. So standard deviation. I just abbreviate it in middle. So to calculate our standard deviation, we input equal to ST. To take notes, ST dev. Then our range A8 to A12. So if you impute it, you are seeing that our standard deviation is at 2.4, meaning that it's still very low. So that's why these numbers also is also closely linked to each other. They're very close to each other. So this is actually how to calculate mean, median, and standard deviation, which are the basic statistical techniques used for data analysis. Basic statistical techniques used for data analysis. Then an extra one also, an extra one also is a count function. Yes, so a count is also a statistical concept, right? A count is also a statistical concept. A count. So a count is giving a measurement to all the occurrences in a set. Yes, giving a measurement. So it's just a matter of counting how many values actually occur in a set. That's basically what a count means. So to actually use a count, you just type in counts. Yes, a count is also a function in the spreadsheet softwares. So counts A8 to A12. So we see that we have five values here. So that's basically what's how a count works. A8 to A12. So take note of that one too. Okay. So that's basically it. That's the statistical basics. So statistics is also an important uh, skill sets, an important technical skill that a data analyst should have also. So while you don't actually need to go very deep into statistics, learning the basics of statistics is also important because for most data analysis um, techniques or most data analysis you'll be doing, you will find out that you'll be needing some statistical techniques to go about your analysis. So having the basic knowledge of statistics and the overall ideology behind statistics is also very important. So remember, central tendency measures central tendency uses measures like mean, median, and mode to summarize data. Then standard deviation shows the spread of data. So it shows the spread of data against the mean. It shows you how varied the data can be. So lower standard deviation values indicates that the spread of the data is very low, meaning that the numbers are closely linked to each other. Then higher standard deviation value shows very high spread of data. So interpreting results helps in understanding patterns and making decisions. Yes, so using central tendency and standard deviation to interpret results helps understand patterns and also helps in making decisions. So if I go back to the sales example, so calculating the mean of the sales for different months or different weeks. Then you also calculate the standard deviation. Then you saw that they are actually closely linked together. The standard deviation is very low. So at that point in time, you just find a pattern. You know that the sales of this business is always within this range. Yes, the sales of this business is always between this range. So you can actually plan ahead of the next month or the next cycle based on the previous estimation, central tendency, and standard deviation value. So that means that based on using central tendency measures to identify patterns and using standard deviation to interpret those patterns, we can also make important decisions that can be helpful for either an organization or even a business that is for profits. So this is why these basic standards, these basic statistics concepts and principles are very important. They also help us in our analysis. So this is basically what we have for today. This is what we have for today. So
Hello,
by
sir.
our next class, we'll be learning about storytelling. We'll learn about data storytelling, and use we'll also utilize all what we've learned so far to actually relate it with data storytelling to actually build something that would be meaningful. So it will be like a um, project that we'll be working on that we can actually relate with. Yes, we can actually relate with. Then we can also pinpoint it to all what we've been learning so far in the previous classes. We've been pointing it to all what we've been learning so far in the previous classes. So that's it for today. So I'll be seeing everybody on Wednesday. Do have a lovely day.
Excuse, sir.
Yes, so I will also be sharing the
Hello,
notes
sir.
group chat so you get to revise it. And yeah, so also endeavor, I urge you to endeavor or making efforts to learning what we've been doing so far. So even beyond the program, right? You could also make efforts to learn. So we are in the age of the internet. You have lots of resources that you can also use to guide. So the program can start as a foundation, but this is not just a one-off program. Once you stop here, it doesn't mean that you should stop. So data analysis is a very high demand skill in the world globally currently is a very high demand skill that lots of organizations actually need, because lots of organizations and even government institutions have been um, understanding over the years, I've gotten to understand the value of data and utilizing data for decision making or execution of projects. So data analysis is actually a sweet spot to be in for somebody trying to pivot into tech or to leverage on digital skills to improve their current career path or occupation. So it's something very important that, okay, even if you don't want to choose it as a career path, right? It's something that learning data analysis would also help. So you see how I've been so far relating it to even our everyday life when we budget items that we want to go and buy in the market, when we make research and everything. Yes. So if you've learned all these data analytics processes, even if you don't want to end up as a data analyst, right? You better know how to apply data analysis to your everyday life activities or even in your work. Also, you'll be able to see certain things and be able to interpret insights from them. So that's basically it. So making efforts to also learn and also trying to find more knowledge with what we've been doing so far is something that I encourage everybody to do. So that's it for today. See you on Wednesday by 3 o'clock.
So you've not dropped to this class.